I want to expand on what we cover in 2.3, the part two about misleading graphs. I want to also talk about what it takes for a graph to be good. So we're going to look at other things that can make for a bad graph. First off, if it's just not labeled correctly. As we look at the two maps, we've got Michigan on Wisconsin and vice versa. We've got Hong Kong being somewhere in Brazil. And to the right, our first two bars there are actually reversed. Proportionally, they're fine. They just swapped the yes and the no. And when you do that, you kind of change the whole impression that you get as the answer, as how people answered that question. Also, if something is missing, a graph should be able to stand on its own. Now, they're typically going to be in a report, so somebody looking at a graph will see it in context. So they're going to know some of the basics of what's going on, but when they look at the graph, all the elements should be identified for what they are. And in the case here, you can see the X and the Y axes aren't labeled. And even though you can see it's a time series graph representing their relationship and it's trending downward, the specifics of it are lost because the X and Y axis aren't labeled. And then sometimes things are just plain wrong. The pie chart, even, I don't know how they've rounded those figures, but 49 and 50% should have never looked like that. And I don't even know where to start on the Zika virus bar chart. It's just wrong in so many ways. So now going to one of the things that is covered in 2.3 is scaling the y-axis from 0. On the left, this graph was used in the original telling of the story. And even with the numbers on there, our minds are trained to make proportional comparisons. The graph on the right is about 2.5, 3 times the graph on the left. And so even with the numbers in there, it's exaggerating the difference. So Fox News caught hell on it, and in subsequent running of the stories, they brought in the labels for the y-axis, and now proportionally the heights are there. Now, 1 million people is still a large difference, but proportionally the graph on the right is telling the correct story. The one on the left is telling really two different stories, the correct one with the numbers, but the wrong one with the the differences in the heights between them. And it's not just them. There's the CNN, the before and after. There again, the difference between starting at 0 and not starting at 0. And even in the corrected graph, there's something I don't like about it. They have too much sky over the top graph there. There's no need for them to go all the way up to 100. There's a lot of empty space there. Same thing with the time series on the top right. Is it starts at the base of 30 million, so it looks like from 2002 to 2009, height-wise from the x-axis on the graph, it looks like it more than doubled. In reality, that's not the case. Now, about a 9 million increase is a significant increase. Don't get me wrong, it's a large increase, but it's exaggerated on this. Also, here's another case where they go all the way up to 60 million as a label there. So they can go up 15 million above, but they can't go down and start this thing where it belongs. So again, not communicating the true nature of the data correctly. The graph is giving a different impression than the numbers should be given. Along the bottom, we got pictographs, and pictographs aren't inherently evil, but these pictographs, the reason they're misleading is they're suffering from the not starting at zero on the y-axis. If you look at the 2007-8 data and the 2013-14 data at the very ends, it looks like it almost tripled. And going from 75% to 82% isn't tripling. So again, the proportional comparison in the heights tells a different story than what the numbers actually are. And it's the same thing with these decreases here in the meat consumption. It looks like it's less than a quarter of what it was in that last year. And in reality, that's not the case. Also, there's a lot of other additional stuff here. There's the map of the continental US. There's the little EKG symbols in there, which I get that they're in there with the context of what the data is talking about. It's physicians, so there's health. It's US meat consumption, so there's the map of the US. But it's all a distraction to what this graph is about, and that is on a yearly basis, the pounds of meat consumed per person. That's what the focus should be on, and it's not in these graphs, in addition to not starting at the y-axis at zero. So the height comparisons are completely telling a different story than the numbers. And we can see this in other forms. In these speedometers here, the speedometer starts at 25. So that's going to exaggerate the differences between the three different browsers. And Microsoft did end up correcting this. So now their speedometer starts at zero, and it, how much faster Microsoft Edge is here according to whatever data they have. The graphs aren't as extremely different as they seem to be here. So again, back to pictographs, they're not inherently bad. When we look at this one here, instead of just using bars, they decide to go ahead and use apples. And if we look at a comparison between April and January, it's a 2-to-1 comparison, and it's actually a 2-to-1 in quantity. February to January, it's a 4-to-1 comparison in the widths that we're looking at. It's a 4-to-1 comparison in the quantity. So you can use pictographs correctly, fancy up a bar chart to bring in some context, even though we should focus more on substance versus style, but pictographs can be done correctly. The error that they talk about in the book is what I refer to as the clip art error, where they go ahead, they bring out a picture, and then they copy it over, and to make it taller, they click on the edge and they increase it in both dimensions. And now, instead of being a comparison in height, we're programmed to compare areas. And the area of the garbage can and whatever that yellow background is for 2000 looks to be over 4 times that of the 1961. When if we just look at the heights, it's about 250 to 100. So it's about a 2.5 time increase, but we're actually seeing a difference in area that's 4 to 6 times different. So, here's kind of an example of it where if B has 3 times the quantity of A, and you do the clip art thing where you copy this little guy here, and and then when you move over to B, you take them and you drag them up to get the height to 3, but you also triple the width. And now you can see here that B is 9 times the area of A. So it's a 9-to-1 difference in area, but in reality, it's a 3-to-1 difference. You can do this correctly if you would have just stacked 3 of these little guys on top of each other. Pictograph is perfectly fine. And one of the going back to the previous example, one of the other things here is it's an odd-shaped trash can. Having the trash can lid open, it's just very difficult to read, and almost the worst mistake of it, if that's even English, the worst mistake of all with it is they forgot to include him. So again, pictographs aren't inherently bad, but a lot of people do them badly. So looking through the different examples here, what you see is the differences in the graphics don't line up with the numbers. So in the fruit collected, it should be 4 of each, and we're seeing different widths there. With the Brewer Association, bottom left, they go from 22.1 million barrels in 2014 all the way up to 2018. They have 25.9 million barrels. That's about a 20% increase. But if you look at the area of the graphics, that growler is probably about 3 to 4 times the size of the glass back used for 2014. The medals in the Summer Olympic medal count, if you look at Germany, those should stand for about 250 medals each. And when you start looking at the numbers versus the medals, that doesn't match up. Same thing with our little empty bottles, plastic rings, and plastic bags for the worst ocean polluters. The widths of the graphics don't match up with the numbers and the proportional differences in the numbers there. So pictographs aren't inherently bad if they're done correctly, and there's all sorts of people out there that are just doing them horribly, horribly wrong. And a lot of it is because they're choosing to focus on style over substance. That Brewers Association, that's really cool to bring in the different beer-related graphics, but it completely undermines the message that they're trying to convey. And well, pie charts aren't going to escape here. Now, keep in mind in the section, Edwin Tuff is really not a fan. He, I would say, is probably 100% against pie charts. I'm not nearly as militant. I'm only about 99.99% against them. So here's the 3 pie charts that I like. And I like these because the data here is not going to be improved by using, say, a bar chart instead, which is what you would normally use instead of a pie chart. These are times where I think the pie chart is the best way to display the content that is being communicated here. So you can see my 0.01% of using pie charts is pretty much a joke. Sometimes it's not even the pie chart's fault. It's the interpretation of it. So again, and this is why it's so important to check things, know what you're doing. And also, again, pie charts are to be used to show the responses from a single variable. What is the breakdown of all the responses from, say, a single question? And the trouble with the one on the left is they brought in the positive responses for 3 different questions. Would you back Huckabee? Would you back Romney? Would you back Palin? And they shoved them into a pie chart for some unknown reason. On the right, that's actually time series data. So, how many small businesses are left over a 10-year period? So they look after 2 years, 5 years, 10 years. Keep in mind, relative frequency, things need to add up to 100%. Things here are adding up to a little bit more than 100%. Even without a calculator, I can tell that these things add up to something more than 100%. Also, back when we started chapter 2, we said when we organize things into classes, it should be 5 to 20, because when we summarize, we want to summarize into a manageable number. 100 classes is not really a manageable number, and turning it into a pie chart doesn't make it really any better. Even though it may not look like there's an issue here, and again, if you see this in the article, you would know what all these abbreviations for the parties stand for. Because they made this 3D, when we look at a pie chart, area represents relative frequency. And with it being three-dimensional, the things in the front where we see the side of this disk, we're seeing additional area. So what's up front is getting exaggerated, and what's in back or at the top of this is getting minimized because we're not seeing the sides of it there. So if you're going to use a pie chart, again, forget, don't worry about style, worry about substance. Use a two-dimensional circle graph for your pie chart. Otherwise, you're distorting it. It's really just that simple. Finally, here's a pictograph that is done correctly and actually gives you some additional information. So, when we look at the bars there, if there's a 4:2 relationship, we see that it's double the width. What we also get is some additional information. We still get the specific, if you want to call them, data values. If we wanted to know who are all the characters Hank Azaria voiced for The Simpsons, well, we know he voiced 24 based on this graph, but the pictograph is made up of the different characters that he voiced. And we're not covering 2.4 now. 2.4 comes back up in chapter 10. So when we start looking at scatter plots in chapter 10, I'll bring in a bubble graph as well as just kind of what is a scatter plot on steroids. This thing is kind of a pictograph on steroids. So to avoid making bad graphs, ones that are just bad by nature, not complete, misleading, choose the right graph for the data. Make sure things are clearly labeled, make sure that there's a title in there. Keep in mind it's going to be in context of what it's being presented with, but it should have enough information to stand on its own. If there is the y-axis, if you're going to make proportional comparisons, you have to start the axis at 0, and you can only change scale in 1 dimensions. And again, focus on substance over style. Keep in mind, you're communicating the relationship of the data that you have. Your entire focus should be on the data that you have.